Hey everyone, my name is Angela and I'm going to be presenting my final project on this terribly confusing optimization problems. You know the ones. There's always that one farmer who has so many feet of fencing but wants to provide plenty of room for his cows to graze. Well, I figured this was a great final project because I want to be a future high school teacher. And in high school, most students just memorize formulas and don't fully understand concepts. They just want to, pass the test and pass the grade and get out of that class as soon as possible. But as a future teacher, it is my job to make sure they fully understand the concepts that they're writing down on the test papers. And one day I hope to use this illustration to help visualize maximizing area when given a set perimeter. So now for my actual project. Because I needed some numbers to help create my sketch, I came up with a sample problem. The sample question reads, if a flea farmer only has 19 centimeters to create a pen for his circus fleas, how should he set up his pen to provide the most room for his fleas to practice? And while this might seem a little bit silly with fleas practicing for the circus, it gets the idea across about optimizing area when given a set perimeter. So to solve this problem, I constructed a circle and rectangle, which are connected by the circle's radius is one of the side lengths of the rectangle. And since the farmer only has 19 centimeters of fencing, I made sure that the perimeter of the rectangle AECD was 19 centimeters, which you can see over here. And as you can see, as I move point C, the radius changes, which means CD changes, which in turn changes AC because the perimeter has to stay at 19 centimeters. And as you see, I can move point C and the area changes, but the perimeter always stays at 19. And to illustrate this, I created a graph where the x-axis is the length of AC. So as I change the length of AC, point H moves left to right. And the y-axis is actually the area of rectangle AECD. And you can see it moves up and down as the area changes. It gets really close to 0 when I make it super skinny, and then it gets pretty big as the area grows. So hopefully when I show this illustration in my future class, I will have already talked about how to find a maximum and a minimum by finding the first derivative and setting it to 0 to find where the tangent is 0, which means that the tangent of point H would be horizontal and would be parallel with the x-axis. So this illustration really visualizes this concept by showing that when the area of rectangle EACD is at its largest, point H is at the top of the parabola, which is the vertex, and the tangent would be 0. I would also, we're almost there, there we are. This is the maximum area of the rectangle. It does happen to be a square with the sides of the rectangle at AC is 4.75 centimeters, and same with the other side, and we can still see the perimeters at 19. I would also solve this problem by finding the derivative and setting it to 0 to illustrate that these two concepts really are the same idea, and this presentation is just a way to visually enforce that the first derivative does find max and min. So that was my visual representation of optimizing. when given a set perimeter, and now I'm going to answer the prompt questions. So we'll start with content knowledge. So I would want this lesson to cover optimization when given a set perimeter, as I already said, and I believe this lesson fulfills that by illustrating that a max area is when the point H is at the vertex and the tangent line has a slope of 0. And some future ideas for students to look further into is, what if a river is used as part of the perimeter? So technically you only need 3 sides of fencing, which would increase the area. And I was wondering if there was a way to illustrate this in Geometry Sketchpad. And another great question is the max area always a square? As it was in my illustration, it is a square with with all 4 sides being 4.75 centimeters. But is that always the case? Now for technology, we can talk about this lesson plan illustrates my knowledge of Geometry Sketchpad because it connects many topics covered throughout the class. I used rectangles and circles to illustrate finding an area, and I related this information into a graph. And I used several different ideas to construct an understanding of a larger concept. I think my lesson plan differs from a normal lesson because it's based heavily on visuals. And in today's day and age, a lot of students are visual learners, and this will help them fully understand and not just memorize what they're doing when setting the first derivative to 0 and optimizing the max and min and finding the max and min when doing test questions. And the next part is, as a future teacher, I think I would present this lesson in front of a class after I have already talked about finding a max and min from setting the first derivative to 0 and how that's the tangent slope. I would use this sketch as reinforcement, not as an introduction to the concept. Some questions I might ask while teaching this lesson vary. You can ask anything. I can ask several different questions and have the students set up an idea like this for a different problem, maybe not about fleas and circus, but have them go to their own computers if there's time, because school years are busy. So if we have a day off or something, maybe I could have the students sit down and for a different question set up a rectangle and circle and see how that illustrates on a graph. And another question would be, why is the max area always when point H is at the vertex? Well, as I discussed, that's because the slope of the tangent is 0, which is when the first derivative is also set to 0. Well, I hope everyone enjoyed my video and is having a great time with theirs. I wish everyone luck on finals and have a great day.